Good evening, everybody. Welcome to the third session on demonstration of QGIS software. Today we will cover data creation and editing, digitization, setting up of the digitizing environment, adding attributes to layer, editing digitized layer, and checking topological errors. My name is Prasun Gupta and I am a faculty with the Geoinformatics department at IIRS. These slides have been adapted from my friends Shri Kapil Oberoi's session. So digitizing is one of the basic tasks in GIS, the most common task that a GIS specialist has to do. Often a large amount of GIS time is spent in digitizing raster data to create vector layers that you use in your analysis. Vector features are captured from a base map, could be a georeferenced map, satellite, or an aerial image. QGIS has powerful capabilities to digitize raster data. In this session, we will take the georeferenced topo sheet and digitize it to create a vector layer. This georeferenced topo sheet is the same that we created from the yesterday's exercise. We are using the topo sheet which is part of Dehradun, that is georeferenced and reprojected in datum WGS84 and projection system UTM44 North Zone. The first step before starting digitizing is to load the georeferenced map in QGIS. Raster layers are loaded either by clicking on this button shown, Add Raster Layer. This button, which appears on the left hand side pane of the software. When you bring your mouse over it, you will see a pop-up comes which says Add Raster Layer. You can add the raster layer by clicking on this button, which is there on the side toolbar, or you can click on the menu option layer and select the option Add Raster Layer, the menu option. To show you the menu option, let me go back to the next slide. The menu option you will get by clicking on this menu option here, layer. Once you click on it, a drop down will come, and in the sub menu option, select Add Raster Layer. Once you click on that, a box will appear which says open a GDAL supported raster data source. Here, navigate to the folder where you have kept the dataset provided. So I have saved it with the name projected.tif. Can select that and click on open. If you are not able to locate your file, you can use this drop down option here where the mouse is pointed, which says GeoTIFF currently. You can click on that and select the file format in which your file is. If you are using the file given today, keep this at GeoTIFF, or if you are using some other file of your own, which is, let's say, in IMG format or any other format, you can select that option in this drop down here, and then your files will be listed here. Select your file and click on open. You will see that your georeference layer or map gets added. The name of the layer will be listed here with a cross sign. That means it is enabled, and it can be viewed on the map canvas. This area, which I am highlighting with the pointer, is called the map canvas. Here the dataset will be displayed. Now the next step is, after loading the georeferenced file, is to create a new shapefile. The new shapefile can be created by clicking on the menu option layer, and then in the sub drop down select the option new, and then in the another sub option drop down select new shapefile layer. Once you click on this layer new, then new shapefile layer, a box will come up like this which says new vector layer on the top. The first option it asks is the type of vector layer you want to create. In most file formats, a single file can store a single type of vector data. That means one shapefile can be of point type, or it can be of line, or it can be of polygon. Two or all three types of vector data cannot reside in a single shapefile. You require different shapefiles for different types of vector data. So in the first attempt, we will try to create a point shapefile. So we will select this option point. Second, we have to specify the coordinate reference system or CRS. By default, the option given here is EPSG 4326. As we discussed yesterday, this is the code given to the projection system latitude longitude in datum WGS 84. So in the current demo, we are working with a projected topo sheet which is projected in a UTM 44 north zone. We will specify that CRS. So we click here on this button, specify CRS, and then in the box which comes up next, which says coordinate reference system selector, you can type here either the EPSG code for the zone, which is 32644. You can type that number here, or you can type the name of the zone or name of the projection system, which is UTM zone 44. Once you type this, a subset of the list will appear here. Click on the selected projection system and then click on OK. The projection system that you will select for this demo is WGS 84/UTM zone 44N, which has the EPSG code 32644. Once the projection system is set, you can see that projection system will appear in this box here. The next thing that we need to do is to specify the attributes required for this layer. By default, if you see the attribute list which comes here in this box below, which has the columns name of attribute, type of attribute, its width, and the precision. This precision is required for real numbers, that is numbers which have a decimal point and values after that. So by default, an attribute by the name ID is already created. We will add a new attribute by the name. So you type the string name here in this box which says name, and then a box is here. You type the string name. In the type drop down, select text data. These has 4 values: text, whole number, real, and date. So these are the 4 types of data columns which can be created: text, whole number, real, that is floating point values, and date. So here we will select text data, and we will keep the default value of width, which is 80, and then click on this button which says add to attribute list. Once you click on it, the information that you have entered here will appear in this table below. So name, text and 80 will come in a new row. Similarly, you may add further columns. If you want to remove an existing column or make changes, you can select an attribute and click on remove attribute to delete an attribute which has been created. Interestingly, you can also remove the ID attribute which is there by default. Once you have specified all the attributes that you want, you click on OK. In case you forget to specify an attribute and you want to do it at a later stage, that is also possible. That I will try to discuss towards the end of the demo. Next, once you click OK, the next thing it immediately asks is, where do you wish to save the new shapefile? So go to a predefined location, write the name locality or any name that you wish, and click on save. By default, this creates the ESRI shapefile format, that is with the extension .shp. So you write the name string locality and then click on save. This will create the file and it will add to your map canvas, an empty file. For each feature that you want to create, we first digitize the geometry. That means for a point we specify where the point is, or for a line digitize the whole line, or for a polygon we create the entire area feature or the polygon feature and then enter its attributes. So as soon as you complete the digitization, for each feature a pop-up will come which will ask you to enter values for all the attributes that you have mentioned in this area here. To digitize the geometry, left click on the map area to create the first point of your new feature. For lines and polygons, keep on left clicking for each additional point which you wish to capture. Once you have finished adding points, right click anywhere on the map to confirm you have finished entering the geometry of that feature. The attribute window will appear, allowing you to enter the information for the new feature. So how this works is, you have to first click on the toggle editing button and then click on the map canvas, enter the point or select where you want to put a point, and immediately after that enter the attribute values, click OK and then go on to the next point. To help you do this, there are some basic editing. There is the basic editing toolbar which has the following options. These icons reflect the purpose. So this icon here is for current edits. Then there are options for adding features, that is capturing a point, capturing a line and capturing a polygon. Then there are options to move the entire feature. There are tools to move a single node at a time. There is an option to delete a feature if you have done it by mistake or you wish to delete a feature. There is an option to cut a feature, copy features, paste features and save layer edits. Once you're digitizing many features and you want to save in the middle, you will select this option or you click on this icon to save layer edits. Now, to start digitizing, make sure your layer name is selected. If the layer name is not selected or another layer name is selected, which is not a vector, then this button toggle editing will be disabled by default. So make sure your locality layer is selected. By selected, I mean it is clicked on, left clicked on once. Next, click on this button, which is shown in the red circle here. If you bring your mouse over this icon, you will see the text toggle editing. Toggle editing means you can turn on editing or turn off editing with the same button. So once you click, once editing is off, if you click on this button, editing will become on. Once editing is on, if you click on the button again, editing will become off. This is one way to start editing. The other way is you can right click on the name of the layer here and the option toggle editing will come as text in the menu. Then click on that, select it. Once the editing is on for a feature layer, click on this icon here which says add feature. Click on it to select it and then click on any place where you want to add a point. So in the current exercise, we will try to give a single point for the names of localities that you can identify on the topo sheet. So in the topo sheet, in this topo sheet, I can see the name Hathi Barkla, which is a locality close to IIRS. Can be seen clearly in the topo sheet which you have or any other image. If you can identify the point feature, just zoom on it using the magnifying glass and left click on the map to capture the point. All you need to do is just left click once and the point data will be created. Once you left click, immediately after that, a box will come which will ask you to enter the attributes. The number of fields here will be same as that you have entered initially when creating the new shapefile. So we had created two attributes, one is ID and the second one is name. So we write one, ID was of type number, so we write 1 here, and in place of name I write the name of the locality, which is Hathi Barkla. Similarly, you can draw points for other features on the image. Once you are done, that is, once you are done creating features, again click on the toggle editing button to stop editing. A pop-up will come up which will ask you, do you want to save the changes that you have made in the layer? Just click on yes and the save and the edits will be saved. If you want to modify existing features, so for example, if you want to delete, edit, undo or save features, all the options for that is available to you in the basic editing toolbar. Current edit tools, choose rollback edits to undo changes. So there is an option to roll back for selected layer. if you select that, the last change that has taken place or last edit that has been done will be rolled back. That means will be undone. To delete a point, first select the feature using the select single feature tool. So on the below the menu bar in all the icons, you will see one icon which looks like this. If you take your mouse over it, a text box will pop up which says select single feature. Once you click on that and then drag over the point or just click on the point that you want to delete, select that and then click on, once the point is selected, click on this button here which says delete selected tool. So once you click on that, the point which you have selected will be deleted. Similarly, if you want to move the selected feature, if you have created a feature and you want to move it, can select it and then use this tool to move it to another location. And to save the changes that you have made or to save changes regularly, click on the Save Edits button to make this to save the changes. Regularly saving the changes is a good habit. Before we can edit vertices, we must set up the snapping tolerance and the search radius. The snapping tolerance, it is the distance QGIS uses to search for the closest vertex and or segment you are trying to connect when you set a new vertex or move an existing vertex. If you aren't within the snapping tolerance distance, QGIS will leave the vertex where you release the mouse button, instead of snapping it to the existing vertex and or segment. So this is basically related to the GIS operation snapping. If you wish that when you are digitizing a road or digitizing a building, the nearest next building or next road that you digitize should continue from where the last feature was left, you have to specify the snapping tolerance. The snapping tolerance can be in map units. So let's say your map is in meters, then the distance can be given in meters, or the information can also be entered in the pixels. Search radius, it is the distance QGIS uses to search for the closest vertex you are trying to move when you click on the map. If you aren't within the search radius, QGIS won't find and select any vertex for editing, and it will pop up an annoying warning. Snap tolerance and search radius are set in map units or pixels. The advantage of choosing pixels is that the snapping tolerance doesn't have to be changed after zoom operations. You need to experiment to get them set right, the values of snap tolerance and search radius. If you specify too big of a tolerance, QGIS may snap to the wrong vertex, especially if a large number of vertices are there in the proximity. So you have to be careful with the values of snapping tolerance and search radius. So to specify the values, you can set these values in general, that is throughout the project the snapping tolerance values will be constant. To do that, in the menu you will get an option called settings. click on settings, go to options, and then in the options box, select the option digitizing uh, as highlighted by the mouse pointer. So click on settings and then click on the sub-menu option options. In the box that pops up, select the option digitizing. Here you will see an option called snapping. Inside this option, you will see multiple other text written. The values important to us here are default snapping tolerance and search radius for vertex. These values can be written here, typed here, and can be specified either in pixels or in map units. This snapping options can be defined specific to one layer also. To do that, you have to right click on the layer, go to settings, and then change the snapping options. So in this case, if we specify the values here, then these are applicable to all the layers in the project. Whereas if you do this, it is specific to one layer at a time only. The option of topological editing is also available in QGIS. Besides layer-based snapping options, you can also define some topological functionalities in the settings snapping options menu. So right now I have only one vector layer locality that is coming in the snapping options box. This allows me to snap either to vertex or to segment or to both within a tolerance value which can be given here in map units or pixels, and can also be specified with respect to another layer. If this option enable topological editing is enabled, you can also activate the column avoid intersection, which avoids intersection with new polygons. So we saw how to digitize a point layer. Similarly, if you click on layer new shapefile and you select the option line in the new vector layer box, you can create a line layer. So let us try to do that. Next, we specify the coordinate reference system. We add some attributes and I click OK. Next, I specify where I wish to save it. Let's say I call the name of the layer as railway, and I can see the railway line clearly in the topo sheet, which I wish to digitize. So again, you right click on the layer, click on toggle editing, click on add line feature, and then click on the starting node, left click once on the starting node, and then left click again on the next point, then left click again on the next point, and so on. Continue to do till you have reached the end of the railway line. Once you have finished clicking on the last point, right click anywhere in the map canvas to stop editing. Once you right click, you will be asked to enter the attributes. Once you enter the attributes, you can see the attributes will come in the attribute table also. So here I have digitized one railway line. It goes from here till here, and I have entered this attribute information. Using snapping, you can avoid topological errors. For example, these are three main roads which intersect in central Dehradun. If you look carefully at this image here, image number 2, this road which is coming from the east has overshot the intersection by a very small distance. You can see the green road, the road in green color, which is overshooting the intersection by a small distance. If you enable this option, snapping, and you give a tolerance value here and click on OK, the next time you are digitizing this road, and as soon as you come close or within the snapping distance that you gave here, the point will automatically snap to the intersection of these two roads. Once you click on it, the three roads will be intersected correctly at a single point, and overshoot or undershoot can be avoided. So this is an example of how beautifully all the three roads are intersecting at the same point when the digitization was done with snapping tolerance set. Now we will see how to digitize a polygon feature. So again, same option, new layer, new shapefile. Select the option polygon here. Click on specify CRS and type 32644, which is the PSG code for UTM zone 44N. Type name here, click on add attributes and click on OK. Specify the name where you want to save the output file and click OK again. Zoom on the bottom left hand corner of the topo sheet provided. You will see an area marked in green with the text written as Asarori RF, which possibly stands for Reserve Forest. How enable editing? Just right click on the layer and say toggle editing, or you can click the toggle editing button. Then click on the add feature tool, that is add polygon, and then left click on the starting point, then left click on the next node, then left click on the next node, and so on, and trace the entire boundary for the forest patch. Once you have clicked on all the nodes that you wish to do, then right click anywhere, then that will stop the editing and enter the attribute values. So here I am showing an example of how after editing the polygon and entering the information, it appears in the attribute table. The next is, now we will talk about the editing tools. The first is the node tool. This helps in selecting the vertices, adding or deleting them, and moving the vertices. So once while digitizing, if the nodes are incorrectly placed, they can be selected and edited using the node tool as highlighted here. When digitizing adjacent polygons, you can select this option here which says avoid intersection of new polygons will avoid overlaps in polygon mosaics. It is for quicker digitizing of adjacent polygons. So for example, you are digitizing two forest boundaries or two polygons like this, the one which is shown in green and the other one which is shown in red, and you want the common boundary to be maintained. This option shown here, avoid intersection of new polygons, will help you maintain a common boundary between the two polygons. This will avoid any overlap and the exact same boundary will be replicated. If you try to do the same thing manually, it is very difficult and it is error prone. This tool will minimize the error in digitizing adjacent polygons. Even if you try to move the common boundary without selecting topological editing, you may get some holes in between which are known as sliver polygons. If the enabled topological editing, this option on the bottom is enabled, this will also help you identify topological errors and edit them. So for example, in case the two polygons are already made, it will help you identify that there is an overlap and the common area can be removed as shown in figure 2. Now, those were the basic digitizing features. There is an advanced digitizing toolbar with more options. There are options to undo and redo the activities. You can rotate a feature, you can simplify features, can add a ring or add a part to the existing feature. You can fill a ring if there is a ring in the feature. You can delete a ring, you can delete a part, reshape features, offset curve, split features, split parts, merge selected features, merge attributes of selected features, and rotate point symbols. So these are the different advanced digitizing features which are available in the advanced digitizing toolbar. Undo and redo are the basic ones. Once you click on them, a box will come which will show all the steps that you have performed. You can selectively undo and redo any of the steps which are listed here. The add ring feature allows creating ring polygons inside an existing area. So if this is the existing area and you want to remove a part from inside the polygon, that is create a ring, the add ring functionality can be used. This will digitize further polygons that will occur as a whole. So only the area between the boundaries of the outer and inner polygon remain as the ring polygon. So this will form in a ring shape. Similarly, there are other features, delete, fill, add part, delete part, and so on, which are used for different other purposes. Split feature will help you split a polygon into two halves. Here you only need to specify the boundary line in an existing polygon and it will be broken into two polygons. This will also help you update the geometry columns. So if you look carefully, initially the forest polygon is of 1 lakh square meters. After splitting into two, there are two polygons which are formed, one of 65,000 square meters and another of 35,000 square meters. Interestingly, the attributes that you are adding after digitizing each feature, a domain of values can be specified. A domain of values means a lower and upper limit or a set of values. So for example, you are digitizing a forest boundary and the type of forest can be reserve forest, protected forest, open forest among these three values. So those three values can be mapped in what is known as value map or domain. So this can be done by going to the properties of the layer. In this option called fields, there is an option to add domain values. A value map can be created such that once you create a new polygon and you have to specify the type, instead of giving a text, it will come as a drop down with 2-3 values, whatever you have given, and the user can select one of these values. This will help you minimize data entry errors and will allow you to maintain data consistency. Similarly, a range of values can be given. So for example, you want to take user input for ID, which should be great. Minimum value should be 0 and maximum value should be 1000. So those can also, such kind of restrictions can also be put. Once your digitizing is done, you can also check for digitizing errors. QGIS has built-in topological editing feature for creating new features without errors. But existing data errors and user-induced errors are hard to find. A new plugin called Topological Checker plugin helps find out such errors through a list of rules. These rules are created by the user. So what kind of rules can be created? That topological rules that could be applied are either single layer rules or multiple layer rules. In case of polygons, you can apply rules such as the layer must contain another layer, must not have duplicates, must not have gaps, must not have invalid geometries, must not have multi-part geometries, two features or two layers must not overlap, and it must not overlap with a specific feature or specific layer. On the similar lines, set of topological rules are also available for line layers. That is, endpoints must be covered by, must not have dangles, must not have duplicates, must not have invalid geometries, must not have multi-part geometries, and must not have pseudo nodes. Topological rules can also be applied to point layers. The rules that are available are must be covered by endpoints of, must be inside, must not have duplicates, and must not have multi-part geometries. So these are the topological rules which are available in the topology checker plugin. So once you install the plugin, we saw how to install a plugin in yesterday's session. A box like this will pop up which says topological checker. Here you can configure new rules So for example, this uh, box shows three rules which have been entered, which is must not have dangles, must not have invalid geometries, and must not have multi-part geometries. So these three rules have been added here, and these apply to these rules, these layers. As I said, they can be multiple layer. So you can have one layer or two layers, and you can also specify a tolerance value. So multiple such rules can be set by clicking on add rule button here. If you wish to remove a rule, you can click on this button here to remove a rule. Once all the rules are set, click on OK, and then once you check them, all the topological errors will be highlighted, which has to be fixed manually. So for example, here it shows that there is a topological error, that is a dangle is created, and it is highlighting the area where the dangle is there. So as we saw, there is an overshoot which is happening here, and that has been highlighted. The user can select it and modify it appropriately. Lastly, you can create and validate multiple such topological rules. In this example here, we are trying to show how topological rules are applied to polygons. So once I have 2-3 polygon layers, I can create multiple rules on them, such as adjacent or buildings should not overlap with each other, buildings should not overlap with water bodies, buildings should not overlap with other buildings, and they should not have gaps or invalid geometries. Once these rules are set, the topological error will give you or point out that possibly these are the polygons which have some errors in them. They can be checked and modified accordingly. So this is about how to digitize using QGIS and to check for topological corrections or to implement topology in QGIS. Thank you.